Okay, for chassis switch, now there are two types, S97 and S77. These chassis switches have much higher performance than box switch, so we always deploy them in the core layer and aggregation layer, like this, in the core layer for some small and medium-sized campus networks, and aggregation switch for large-sized campus networks. These are all the Huawei series switches, and this lecture is going to introduce 77, 97, and for 93 now it's not used in enterprise market. It's only used sold in carrier market. For 97, it has three types: 9703, 06, and 9712. This 3, 6, and 12 means the service slot of this switch. The service slot. It has 3 service slots. It means we can insert 3 interface cards into this switch. And also, their backplane capacity is here, and switching capacity are different. These are the maximum port density of these 3 types. And for this one, as 9712, maximum of the ports we can have 576 GE ports or 24 100 GE ports. So next, I will introduce the physical architecture of our switch. And so as we know, 2 types, 77 and 97. For 77 and 97, they look the same. Only difference is the performance. Performance is different, but they look all like this. And the slot spacing are 1.4 inches. So the power input or support AC power and DC power. For 03 types, the MCU, the monitor unit, is built in the main control unit. But as 06 and 12, they have an independent slot for the monitor unit, and they can make a one-to-one backup. Others, like the installation space, it can be installed in N66 cabinet, which is the larger than 600 millimeter steps. And all the fans support the speed adjustment. All the power supply, the fan module, they can provide 1+1 or 2+2 backup. So this its different slots function. Here, this 3 slot, this is 03 and 06, 12. These slots, they are LPU, LPU. LPU means the line processing unit. Line processing unit, it means we can insert the interface cards into those slots. And this, and this, they are control boards. They are like the brain of the chassis switch, the main control boards. So the CPU or the processing, the routine processing are on the main control boards. Here for 06 and 12, it has the independent monitoring units. The independent monitoring units are inserted here. And here, these slots are used for the power supply. So it can support 1+1 and 2+2 redundant. On the rear panel, these are the fan tree. Here for S9712 or 7712, they support up to 12 LPUs and 2 SRUs. SRU are main control board, the main control board. It names switching routing unit, and the power supply areas are at the bottom of the chassis. The air filters are on the left of the chassis, and the cable tree is on the right of the chassis. So here on this picture, these are the slot number, and the slots function, the LPU slot, the SRU slot. Here is the cable tree, here the air filters. And for the power, 2+2 power redundancy, and here we can insert the monitor card. And if we want it to support PoE function, we need to insert the PoE power supply here. For 06, no big difference, only the height is lower than the 12 series. And the LPU slot for this one is only 6. Only the LPU, the number of the LPU slot. And for 03, this type only 3 LPU slots. So we can deploy this type in some small sized enterprise network. And for this type, the main control unit is smaller than the other 2 types. So they share this one big slot into one sub slot. Next is the logical architecture. For logical architecture here, these are the logical architecture of 06 and 12. Here, the most important parts here are SRU, the switching routing unit. It means all the switching and the routing functions are here. One is active, the other is standby. These are LPU card, the LPU slots. All the LPU slots, they are connecting to the switching fabric. It means all the inter-slot communication must from the LPU to the switching fabric, then go to other slots. And also the SRU need to control and manage all the other slots. For 03, because there are only 3 LPU slots, so we don't need a switching fabric. We just deploy them like a full mesh structure. So each of the 2 slots, they are connecting to each other. Then if they have traffic across the slots, they just directly send to each other. So in their main control board, there is no switching fabric. Okay, next I will introduce the control boards and monitoring boards of chassis switch. The control board of the S77 or 9712 or 06 is SRU, the SRU. The SRU board provides these functions like integrates with the switching fabric unit to implement cross LPU service switching, processes packets, calculates routes, and creates and maintains forwarding entries, provides system configuration and management functions, manages LPUs and devices, and upgrades the reset LPU software. So the SRU is like the brain of the chassis switch. And the control board of S77 or 9703 is MCUA. And MCUA, the only difference with SRU is there is no switching fabric in MCUA, because all the LPUs on 03 type, they are full meshed connected to each other. And for SRU, we have different types of SRU. SRUA, SRUB, and SRUH. Different types, they may have different performance. So on the SRU, we have a console port and a management port, reset button, and some indicators. This is SRUH. Also a sub card here, a sub slot. We can insert some sub card into this slot to provide the more interfaces and the CSS function. SRUC, different types, and SRUD. And on the SRU, there are some buttons, like the run alarm button. If it's green, means it's power on, and if it blinks slowly, means it's running normally. If it blinks quickly, means the system is being power on. If this button is red, means it's steady on the board is 40. If it's orange, means this slot, this card is inserted in the sub rack and is installed. And the CAN bus is powered on. For the ACK, means active, because all the SRU, they are 1+1 redundant. So one SRU is active, the other one is standby. So if the ACK, this button This indicator is steady on, means this SRU are active one. And the other one, if it's off, means it's standby. The reset button is used to reset the board. And some indicators on the ports. Some indicators on the ports is easy to understand to indicate if the ports are up or down. And USB indicator. USB port is used for USB-based deployment. So if it's green, means if it's steady on, means the USB-based deployment of the card has been completed. If it's fast blinking, means the card is reading data from a USB flash drive. And the yellow means the card has finished reading data from the USB flash drive. You can remove the USB flash drive now. And if it's red, means the card fails to connect to network management system or fails to register with the NMS. Like this. Okay. Next, the synchronize. This is used for clock synchronization. And the CSS ID, this is used for CSS function. So there are 8 CSS ID indicators on the panel, but only one is on at a time. As a CSS ID N is steady on, means the CSS ID of the local chassis is N. Okay, this is kind of the subcard of SRU. This subcard can provide 4 16GE optical ports for data transmission and line speed switching. Also can support the cluster switching system, the CSS function. We can use this port for CSS to connect each other, to connect different chassis switch to establish a CSS system. Another type of subcard are like this. This can provide 8 10GE optical ports. 10GE optical ports, 8. And these ports also can be used for service port and CSS port. This is a monitor card of the chassis switch. And for different SRU, we can see their switching capacities. They are different. And MCUA, for now, only one type. Next, service board and enhanced service board. For LPU board, we can choose different types of the interface cards to insert into the LPU slot. Basically, there are 2 classes, the standard LPUs and enhanced LPUs. In different classes, there are some sub-series. This series doesn't support MPLS, so it belongs to the low-end boards. And the F series is high-performance price boards with MPLS function. If it's E series, this supports MPLS and belongs to high-end boards. The B series means big cache. Big cache beside 1.25 gigabytes cache. So BC board share the same parameter with the EC board. And these are the boards of the chassis switch. We can choose different types based on our service. And here is the summary of the boards. The control board and subcard. We can choose different control boards and some subcards to insert into the control board. And the monitor board. Monitoring board only support 06 and 12. Others are the Ethernet LPUs. The Ethernet LPUs, different number of the ports, different bandwidth. Also, it supports the WAN LPUs. This WAN LPUs, they can provide the POS interface. Okay, next is S Series chassis switch product characteristics. Here, in enterprise network, we can access different services like mail, VoIP or video conference or VPN. Use some 57 box switch. Then, in aggregation layer, we can deploy S77 and using a CSS system. Also in core layer, we can deploy S97, use CSS system. And in data center, here this switch could be S67, and also here use CSS system to deploy 97 or 77. Okay,